All right, so example 3 is asking us to prove that n 2 to the nth power is greater than 1 plus n for all n greater than or equal to 2. So the first thing is I would write the statement that Pn is the statement 2 to the n is greater than 1 plus n. Then I'm going to say when n is equal to 2, I'm going to get 2 to the what? 2 on the left hand side. And on the right hand side, I'm going to get 1 plus 2, right hand side. So over here, I'm going to get what? 4 is greater than 3. So Pn is true for n is equal to 2. Then I'm going to assume that Pk, which is the statement 2 to the k is greater than 1 plus k, is true. Then I'm going to be what? Required to prove that Pk plus 1, which is the statement 2 to the k plus 1, is greater than 1 plus k plus 1, which is greater than 2 plus k. I'm required to prove that. So to prove that, I'm going to start out with something I assume to be true, which is that 2 to the k is greater than 1 plus k. Now, if I multiply both sides by 2, I'm going to get 2 to the k plus 1 is greater than 2 plus 2k. So 2 to the k plus 1 is greater than, so this must be greater than 2 plus k. And the basic reason for that is k is a positive integer that is greater than 2. Therefore, 2 plus 2k must be greater than 2 plus 2k must be greater than 2 plus k. Therefore, 2 to the k plus 1 must be greater than 2 plus k, which is what I was asked to prove, which is what I was required to prove. So at this point, I'm able to now make my statement that Pk plus 1 is true when Pk is true. Therefore, Pn, which is the statement 2 to the n is greater than 1 plus n, is true for all n greater than and equal to 2 and is an element of the set of natural numbers. So next we're going to look at example 4. Example 4 is asking us, or example 4 says, a sequence of positive integers is defined by a subscript n plus 1 is equal to an squared plus a quarter, where a1 is less than a1 is less than a half. Prove by induction. All right, so this is what we have to prove by induction. So that is my Pn statement, that an plus 1 is less than a half. All right, so I'm going to say when n is equal to 1, I'm going to have what? A to the 1 plus 1 is less than a half. So A to the 2 is less than a half. All right, so that is not enough proof. That's all it's saying. It's saying A to the 2 is less than a half. Now let's come back to the defining equation that A to the n plus 1 is equal to a n squared plus a quarter, and that a1 is less than a half. Now when n is 1, I'm going to get a to the 1 plus 1, which is 2, is equal to a to the 1 squared plus a quarter. Now a1 is less than a half. Therefore, if I square both sides, I'm going to get what? A1 squared is less than a quarter. If A1 squared is less than a quarter, A2 would be less than a quarter plus a quarter. A2 would be less than a half. So when I work it out using the formula given to me, which is a n plus 1 is less than a half, and I work it out using the given information, the defining equation for the defining statement for the sequence, along with the fact that a is less than a half, a1 is less than a half, I also got that a2 is less than a half. So therefore now I can say Pn is true for n is equal to 1. I can also assume, this is a step, that Pk, which is the statement, a k plus 1 is less than a half, is true. Then I'll be required to prove that P, k plus 1, which is the statement a, k plus 1 is less than a half. I'm required to prove that. And I must use or utilize the fact that a, k plus 1 is less than a half. Now, this is Pk. So somewhere in my proving of Pk plus 1, I must utilize Pk. So starting with, go back to the defining equation, which is a to the n plus 1 is equal to a n squared plus a quarter. When n is equal to k plus 1, I'm going to get a to the k plus 1 would be equal to a to the k plus 1 squared plus a quarter. But over here, a subscript k plus 1 is less than a half. Therefore, a k plus 1 squared would be less than a quarter. Then come back over to the left. A k plus 2 would be less than a quarter plus a quarter. So a k plus 2 would be less than a half. And this is what we're asked to, this is what we were required to prove. So now that that is true, I can now make my statement, which I will make over here, that P k plus 1 is true when Pk is true. Therefore, P n, which is the statement a to the n plus 1 is less than a half, is true for all n for all n, which is an element of the set of natural numbers. All right, so there's a B part of the question. The B part of the question says, hence show that A subscript n plus 1 is greater than an. So we're to show that n plus 1 is greater than an. Now, how are we going to do this? All right, we're told hence means that what we're going to do, what we just done, must be using what we're going to do next. All right, I'm ready. This is our defining equation for our sequence. N plus 1 is equal to an square plus a quarter. Here's what I'm going to do. I'm going to add, subtract an from both sides. So I'm going to have an plus 1 minus an is equal to an squared minus an plus a quarter. This is my objective. My objective is to show this. That's my objective. That's what I'm going after. My starting point, the equation that defines my sequence. Then I subtracted a subscript n from both sides. Over to the right, this is an squared minus 2 times a half an plus a quarter. Still the same thing, because a half times a half is minus 1. But I can factorize the right-hand side now to this. An minus a half squared. All right, stay with me. So now what I have is what? N plus 1 minus an is equal to an minus a half square, which is greater than 0. Why is it greater than 0? It's greater than 0 because an, the square of something must be what? Positive. So if the square of something must be positive, it must be greater than what? 0. So therefore, an plus 1 minus an must be greater than 0. And so an plus 1 must be greater than an. And that is what we were asked to show at the ending part of this question.